A quadratic equation is an equation that has a lead exponent of 2. These are equations that feature at least one term with x squared. More complex quadratic equations become more challenging to solve. However, some one-step quadratic equations can be solved very simply using our inverse operations. On your own, pick any value. I'm going to use 3. If I square 3, I get 9. Now I want to do the inverse of that. I want to take the square root of 9. When I take the square root of 9, I get back to 3. Square and square root, these are inverse operations. When I square a value, I'm taking a value and multiplying it by itself 2 times. When I take a square root of a value, I'm finding two values that can be multiplied together to create the starting value. In your own words, what is the relationship between squaring and a square root? Squaring and square roots do the exact opposite of one another. They are inverse operations. We like to say that they cancel each other out, leaving a variable by itself in an equation. Understanding equations, we can look at them at 3 different levels. At the most complex level, we can look at an equation as mathematically determining, or solving an equation as mathematically determining the known value represented by a variable or variables that makes the statement true. We've explored this definition of solving an equation when we've plugged values back in to check if we're correct. If we have the correct solution, when we substitute that solution back in, it'll create a true statement. Level 2 describes the process of solving an equation. We're using inverse operations to move values from one side of an equation to the other, keeping the equation balanced. We're moving all the values away from the variable. We want to get the variable all by itself, which is the simplest definition of what solving an equation is. We need to get that variable by itself. It needs to be a variable plus nothing, a variable times 1 at most. Look at this example. We have x squared and we have 4. We assume that they're equal because they're on a balanced scale. What value could x equal that would make this statement true? How did you find this value? How did you solve for it? Try this problem and then move on when you're ready. When we solve equations, we have to think about a zipper. Inverse operations do the same thing, just like a zipper does, in opposite directions. A zipper zips up, a zipper zips down. Originally, this equation had to be put together using the order of operations. So I need to analyze it for the order of operations. I ask myself, what's happening to the variable? Well, in this case, I have x squared. The operation that's occurring here is an exponent. Now I need to ask myself, how do I undo the operation? This is really asking, what is the inverse operation? What's happening? It's being squared. How do I undo it? I square root. I apply the appropriate inverse operation to both sides of the equation in order to keep it balanced. If I do something to the left side, I need to do it to the right. Just like if I take a pound off a scale on the left side, I need to take a pound off the right or it'll be unbalanced. So I'm going to add my square root symbol to both sides and then evaluate each side of the equation. Square root of 9 is going to give me 3 on my calculator, and square root of x squared is just going to give me x. The squared and the square root cancel out. Now when I plug square root of 9 into my calculator, it's only going to give me 3 as an answer, but that's not my total solution. When we take the square root of a value, we end up with opposite values. So if the square root of 9 is 3, its opposite value is negative 3. To prove why there's two solutions, try this think, pair, share. Plug 3 in for x and plug negative 3 in for x. When we substitute these two solutions back in, evaluate and see what the final answer is. Also, in your calculator, try square root of negative 25 and square root of negative 36. Write the answer that your calculator gives in the space to the right of each square root. Let's try solving a couple problems together. X squared equals 36. Ask yourself the same two questions we do with every single equation. What's happening to my variable? Well, I'm taking a square, so it's x squared. How do I undo that? I'm going to take the square root of both sides. Square root, square root. Square root of x squared just gives me x. Square root of 36 gives me 6, and negative 6. For our next equation, we ask ourselves what's happening to my variable. X is being squared. So to undo that, I need to use my inverse operation and take the square root of both sides. Square root, so apply the inverse operation, put it into the equation, and then evaluate. The square root of x squared, that's just x. Square root of negative 20.5. When you plug that into your calculator, you're going to get an error or some kind of not so nice symbol on your calculator. That's because you cannot take the square root of a negative value. The square root of a value, or the solution to a square root of a value, represents something that can be multiplied by itself to make the number underneath the square root symbol. There are not two values that can multiply together to make negative 20.5. That's because in order to multiply to make a negative, it requires opposite signs, which means we cannot use the same value multiplied by itself. Anytime you have a negative value that you have to take the square root of, your answer will be no solution. There is not a value that you can substitute in for x that will make that equation true. On your own, try the last two examples. Remember, every equation that has a solution will have two solutions. One will be positive, one will be negative. If you have to take the square root of a negative value at any point, you will have no solution. There is no value that can be substituted in for x that will make that statement true.